Hello and welcome to this Hyperledger Sweden meetup. Today, I hope you are all well. And today, I will give you a short overview what I have prepared for you. Last week, we have done a little bit chaincode development, and we have started to develop a chaincode. And for today's session, I have extended this chaincode. And I would like to show you some special topics in this part. So the first thing what I would like to show you is how we can create a short dev network where we can use the build your first network example and install our own chaincode. So I would like to show you how I have done this and to have a pace where we can use and test our chaincode. And then I have developed, I've extended the chaincode from last session. And in the last session, there were some questions, and I've integrated these questions in this chaincode so we can see how we can solve these problems. And I have also updated the chaincode with some new functions. So we will have an add function, an update function to see how the state is changed. Then the query functions are the same like in the last week. And then I have developed a new function, get all transactions by key. So for me, it was interesting to see how I can query the old states of an asset. And this is done with this functionality. And then the next step would be how I can query such a state from the history. And this is an interesting part. So we can see here, we have chaincode operations and we have SDK operations. And in my example, I have used the same Node.js application which I've used in the second meetup, I think. And I have also extended this Node.js application to do these operations. So, and during this example, I have seen that there was a problem for me to pass values to the chaincode. So in all examples I have seen is a string array where we pass the single parameters or the single values to the chaincode. And that is a little bit uncomfortable. And I have tried to change this. And I would like to show how we can do this, because these values are values in a JSON format. And yeah, this is in part a little improvement I have done in my chaincode. And then through these operations for the transactions and the transaction itself, I have seen, okay, what I have asked me, what is the difference between the key and the transaction? And that's also a part what I would like to show you here. And as I've mentioned in the last session, there were two questions. One question, both related to the couch debate example. So how we can query sub-objects like owner, the name of the owner, address, or something like this. So this I have included in the example, and also the history. So that's the part where we can query the history from an asset. And then one point, one really good point, lessons learned. So I had a lot of problems this week because my network wasn't really working. And also my example from last week wasn't working because of my changed endorsement policy. And in the last meetup, I have shown you my chaincode, and in this chaincode, I had two terrible mistakes. And this mistakes was the reason why my endorsement policy failed. And this is, I think, a really, really good example to know how something you should do in the Fabric development. So, and that's a part I will come in the end of my presentation. So, okay, the first thing, how we can create a dev network to test our chain code. So for this, I need my workspace. So what I have done, I have copied the first network example, and because I have modified some things, so I have changed the CouchDB environment variables, and I have also changed something for the development process, and for this I have copied this one. But important is a second folder. So, and in this second folder, I have created a short script. And with this script, we can start the build your first network and install our own chain code. So, and that means that we can use the build your first network example, and we can start it without the predefined chain code. And we can install our own chain code. So this is the chain code. I will show it a little bit later. And the important part here is we can start the network, and we have here 3 options. So the S option we have seen last week is for CouchDB. So in my example, we would like to use CouchDB because we are going to query the values and not the keys. So the C option is also clear, it's the channel name. And the A option here is stands for certified authority. So when we set the A option, Fabric CA container is started. So we need this for the Node.js application to enroll a new user or to add an existing user to our wallet from the Node.js application, that we can have access to the chain code. And the important part here is the N option. So that means no chain code will be installed. So when you set this option here, then no chain code will install, and you have to install your chain code by your own. So, and when you have developed with the Docker dev mode development containers your own chain code, and you think it's ready to test it in the real network, then we can use this procedure. And that's very straightforward. So I have configured some variables, and then we have to call this docker exec commands. So we have to install the chain code on every peer from both organizations. So as you know, that the test build your first network has 2 organizations, and both organizations have 2 peers, and peer 0 and peer 1. And on these peers, we have to install the chain code. Because when we don't install the chain code on all peers, then we don't have an endorsement peer, so we have only a committing peer. And the committing peer can't be queried because it has no chain code installed and is only only for verification in the Fabric network and for holding the blockchain. So that's important that you install the chain code on every peer which you would like to query, and then you can speak about the endorsement peer. So, but I think that's here everything the same. So we have peer 0, peer 1, everything is the same here, and 0, peer 1 also for the organization 2. And then in the last step, we have to instantiate our smart contract. So the install process is that you have to install your chain code, and then you must instantiate the chain code. And this is done with this command. via Chaincode instantiate, and with via Chaincode install, you install the Chaincode. And when you instantiate the Chaincode, you can set an endorsement policy. And this is the important part here. In our last example from the last week, we used the endorsement policy as well, but we used an OR. So that means that for every valid transaction, at least one member of one peer of each organization has to endorse or has successfully endorsed this transaction. And if this is true, then the transaction will be sent to the orderer, and the orderer push it to the blockchain in the later step. So, but to this I will come a little bit later. So, and with this small setup, we can run the build your first network with our own Chaincode, and then we can play and test a little bit to see how this works. So this is an important helper script, I think. So then when you're going to test your Chaincode in a test environment, so you can play with this. And later in my slides, I have the whole example with the Chaincode, and also with the script is in the you can find this in the references, and you can copy and paste this from the GitHub repo. So, okay, so this is the script we will use to start. And that's the part where I've said, which I've a little bit had problems with that. So how we can pass variables to the Chaincode. So in all examples I have seen, we have this one. So we have the invoke command, then we have here the C option, and then we have here something like a JSON object. But on the first position, we have, this is an array, as you can see here, an array. And in the first position, we have the function. So the first position is the function, and then you have values. So and when it comes to a greater or a larger example, where you have more properties than 4 values, then you will have a large or a huge string array here, and that's not really comfortable. So, and I was looking for a way to improve this. And also here in the Node.js part, then when we use the contract submit transaction function, we have also to pass all variables in this string array to the Chaincode. So, and that was the problem. But as we have seen here, this is a JSON object, and I have modified this so in a way that we can use only one parameter here. So, and we will use a JSON object, and we pass the whole JSON object to the Chaincode. So, and the C option, according to the documentation, the C option says that pass a message for the Chaincode in the JSON format. So, okay, it's a JSON format, and that's the JSON object, and we can pass this JSON object to the Chaincode, and in the Chaincode, we can define a struct to catch this, and then in the next step, the struct will be stored into the blockchain. And that works really good, because we can use it in the creation process. So when we create a new asset, and also when we update an existing asset. So the struct here and the import mechanism in the Golang is very comfortable for this. So it's very easy to pass a string and JSON object with our information to the Chaincode, and in the Chaincode we use the struct design element to build a new object for the creation of a new asset and also for the update from this asset. But we only want to update one property for this asset. So when we have a property or an asset with a name, a street, and different properties, and we only want to update one property, then we can use this mechanism that the next state only has changed one property. So, and that was my thinking of this, and I have improved the chain code to this, and the rest is the same. So on the first position, we have the function, which is to call. So here the add function, and on the second position, we have only a JSON object. So we don't need so much parameters in this line here. So, and with this, we can improve this. Okay, so, and now this is the chain code. This is the modified chain code from the last example. So, and what you can see here is these are the methods. So the green ones are from the last meetup, and the orange ones are the new ones. So, but I had to adjust also the green ones that that the example is working. But really new are the yellow ones. So the update function and the function get all transactions by key. So that's an interesting part because we have an asset, and an asset has different states, and we want to know what is the history from this asset, and then we want to query the asset, and we are going to use and the result is an object array with all transactions we have done to this asset. So that's a really cool thing to see the history. And when you have one transaction, is the next question is how you can query this transaction. And yeah, okay, I have missed this here, but we will see this later on the chain code. And the data model here is that we have the data item as we have seen in the last example. So with the type, a name, a description, and the owner. And the owner is not a string. So okay, that's wrong. So the type is not a string. The type is an owner. It's this owner object here. And the owner has also 3 properties: the first name, the last name, and the department. And new is here the extension here to the type. So the bridge to the JSON object, the bridge between the JSON object and the data object in the Golang, in the struct, is here this notation. So our JSON has a property, it's called type, and it's written lowercase. Also the name, the description, and the owner, for example. So, and that we have seen in the last session. And with this extension, omit empty, this is is one of the keys. So with this extension, we can say, okay, when the imported JSON don't have the name as a property, then the data item will not have this name property. And when we don't use this, we will have this property name, but it's empty. So we have an empty property. And so with this, we can only update, for example, the name or the description. And yeah, so, okay, so now let's switch back to the chain code. So I will make it a little bit larger. So, and here you can see this. Yeah, we see this, the data item, the struct from the data item, and we see the struct from the owner. And we see here the data type is not a string, it's other struct, this struct here. And this is the key, yeah, omit empty. That means that we can say, okay, when this JSON property is not set, the data item will not have it. And this is very useful when it comes to the update process. So then we don't have an empty property in the database. So, and so on the invoke function, so we can close this. So the invoke function is the same as we have seen in the last session. So we can skip this. So, and that function I have modified a little bit. So what I would like to, what I want to see is what is the difference between the key and the transaction. So what is the transaction ID? So, and the transaction ID is delivered through the stub interface, and there's a method, it's called getTXID, and it gives us the transaction ID. And the key we have seen is in the first one. Yeah, so the value name is not really useful, so that should be JSON object for this example. It would be a little bit a better name, but it's basically the same. So, and no. So this was my mistake. So in my last, this is the part from the lessons learned. So in my last example, I've created a unique ID, and that was the problem. So, and in this example, I have skipped this unique ID and from the Chaincode, and I have created this unique ID in the Node.js application. And why I will tell you later in this lessons learned. So that's the key. That's my unique identity for my asset. And in the second position, we have the JSON object. So, and that's the import. So here, that's the import. So here we have a JSON object, and that we can convert this JSON object to the data struct. So we have to convert this first to Python in a Python array. And then we can use the JSON unmarshal function to transfer or to convert this Python array to the item, which we have created here. So, and then we have an item. And then the next step is the same as we have seen. So when we have this item, when we have converted this, we can use the JSON marshal function to create Python again. And this data item JSON as Python will then be stored into the blockchain. So that's the improvement here. So we say, okay, we have here a data object, a JSON object, and we convert this to Python in this variable. And with the unmarshal function from the JSON object, we can create this struct. And then we have to write it to Python, the item to the Python again, and then we can store it with the put state function to the blockchain and with our key. So, and the key we have to remember, this is one of the problems. So, and then we have a result, and when this is ready and we have a success and not an error. So in the last example, the key or only a success message was delivered back. But I want to see what is the key and which transaction ID is used. And for this, I have created a new function, is a get key as Python function. And this has two input variables, the key, which is delivered through the Node.js application to the Chaincode, and the corresponding transaction ID, which we have, which the stub gives us here. So for this particular transaction. And this is an helper function here in the end. So this is this function. So get key as bytes. So, and the return value is a bytes buffer. So, and we can create the return value, the final result. What we are going to, what we like is in JSON array. It's something like this. So we want a JSON, not a JSON array, a JSON object with the properties key and transaction ID. So, and that we have seen, okay, this is our new asset with this unique ID, with the unique key. And this transaction ID is used for this asset. And to deliver, to return, that the chaincode can return this, we have to construct a bytes buffer like this. And then it's basically, as you can see here, it's a JSON object as well. And we have here two input parameters, both are strings. And in this way, we can construct this return value. So, but this method is the same as we have seen here in the construct query response from iterator function, which we have copied last week from the Fabric samples. And the mechanism and the procedure is the same. So, but this is new. So the question was, what is the transaction ID for this particular creation of this particular update process for a query? And that's here in this, with this done. So this is the add function. And also in the update function is now completely new. So here, it's the same. So for this update, this is a new transaction. So we get the transaction ID, and our input parameters are also the same. So to update the key, so we have to know what is the key for this asset. So our unique identifier, and what are the data which should update it. And this also in the first parameter for the JSON object here. And to update this, so, and the problem is now when we say, okay, when we update an asset with two properties and we decide to send only the property which should be updated, then the new state must have the whole asset. So the new state from an asset is the asset, and we change only one value. So I think, I don't know what is better when you say, okay, you send the whole asset with all data to the database, then you don't have to query the state, but when you send only something what is changed in this asset, then you can do this in this way. So here we can query the state from the last state, and this is also important because so we have seen last time that when we are using CouchDB, so we can also have a little bit problems, or we can tamper our data by ourselves when we have access to the CouchDB, and we can change the world state for this. No? So for this, we must be a little bit carefully that we don't tamper our data by ourselves. So, and with the get state function, queries always the world state. So, and we get this, and the result is always in bytes. So, and we do the same process like we have seen in the in the add function. So we create from this data item a new struct, and we unmarshal this, and then we will have the item, the data in this item in this variable. So yeah, that means that's a pointer to this object here now. And yeah, and then we do the same. So in the JSON object must be converted to a byte array, and that's represented in this data object or in this data array now. And then we marshal the data with the item. And that the interesting part here is that when we are going to do this in this way, so only the changed part from the JSON, from the standard JSON document is changed in the whole item. So when we have an item, a struct or an asset with two properties, with a name and with a first name and the last name, and we send the update process only the last name, then only the last name will be updated here. So the first name will stay as it was in the first state, and that when we have created this asset. So, and I think the reason for this is that we use here the omit empty property. So because when this is empty, when we don't send the type or the description, then this struct don't have this property, and then the data, the old data object will not be overwritten with empty property. So, and in this way, we can reduce the traffic to the chaincode, and we can only send from the Node.js application these data which are changed. And the chaincode queries the world state, receives the whole asset, and in the next step, it changed only the things, the properties which are sent to the chaincode, the changed properties. And then we store the whole data item as a new state in the blockchain. So, and with this, we can reduce the amount of data which is sent to the blockchain. So, yeah, and that's basically the same here, as you see. And for the result, I did the same here. So the result is the data item ID. That's the key from our asset, and also the new transaction ID, which we have queried here through this stuff. So, and that is also an important point to know. So the transaction ID there's a transaction ID for every transaction. And the important part is to know there's a transaction ID for every valid transaction and also for invalid transactions. So the transaction ID is for every transaction unique, and is also unique over the blockchain, over the network. So, and that's an important part. In my last example, I have created the unique identifier ID into the chaincode, and this leads to the problem, which I will show you a little bit later. So, and that's an important part here. Transaction ID is an unique ID for every transaction, and it doesn't matter if this transaction is valid or not, because the key is only for valid transactions. Because when the transaction is not valid, then nothing will be stored in the blockchain. And when the asset is not stored in the blockchain, there is also not the key stored to this for this asset. So, and that's an important part. So in the Fabric, it's like an invalid transaction is also stored in the blockchain. Okay, so Okay, so these are the modifications for the update function. Okay, so the query by ID, so it's pretty the same as we have seen. So yeah, this is also the selector. This is for the CouchDB. So when you use CouchDB, then you can use the selector query syntax, what CouchDB delivers. And these are the rules from CouchDB. It doesn't matter, or it doesn't belong to the query, to the Fabric stuff. So, but it's the same. Also, query by owner. This is the we have. And here, this is one question. So yes, we can query sub objects, and because and that's the reason why we are going to use CouchDB. So we can also use LevelDB, as we have seen last week, and but LevelDB is much more secure. So it's not so easy to change the world state because I think for LevelDB there is no unique client available. So the client must be built around the application. And it's much more difficult to modify, to tamper the world state than in CouchDB, because in CouchDB you have the UI and you can change whatever you want. But you have more query functionality, and you can query every object in your JSON object. So because that's a NoSQL database, and it's a JSON-based NoSQL database, and in a JSON-based database you can query every property, and this is called the dot in this dot syntax. So and yeah, you can query everything here, and you can use all functions and operators like in, or, and, or whatever CouchDB provides, and to query the data. So this is the way here, and that's the same as we have seen last week. And the ad hoc query is also the same. So that's the easiest way to query something. So we have here a query string, and we pass this query string directly to the query function here. And with this, you can give the Node.js application a lot of power that he can query everything. So from your data model and yeah, from your assets. So, but this depends on your application. So, but I think not every function which we have seen here is also useful, and it depends really on the use case. And you have to choose your queries and your methods wisely. So because blockchain should be very secure, and you can determine the level of security which your tools you are choosing to use. So when you want to query the values, and then you want to do such cool queries here, then you have to use CouchDB, but you have to note that in this way you reduce the level of security, and you have to protect your CouchDB database more than you have to protect the LevelDB database. So that's something you have to know. Okay, so and now we come to the to a new function. Get all transactions by key. So that means that we want all transactions for an asset. So, and we will see that I will start this in a moment, and then we are going to see when we update an asset. So a new asset is stored in the world state, and we can see this also in the in CouchDB. So there is a CouchDB property. It's called underscore ref, and with this we see the versions. We can see the versions, how many transactions or how many states exists to one key. And with this function, we can query this history. So, and yeah. So, and that's relatively easy to do this. So the Go SDK, the chain code, the Go-Chaincode gives you a method that's called getHistory4Key, and you have only to pass the key. So that's our unique identifier, and that's it. So, and now we don't query only the world state, so we query the blockchain in this thing. So I mean, I'm not exactly sure, but from my understanding, for this, we will not query the world state. So instead, we will query the ledger directly because we want all transactions and all states for this particular key. And yeah, so, and then you have this result iterator, and that's it basically. So then you can construct here your return values. So this is also in the Marble example drinnen. So this is, so as I've mentioned several times, so the Fabric samples has a lot of good examples to learn and to see how you can do this. Yeah? But I think you can modify this, and when you are an experienced Go developer or an experienced Node.js developer, then you can modify this in the in some ways, so to improve this time of doing. So yeah, but this function is also from the Marble example. So it's, but the key is really simple. So you have this one here, and then you have to construct the buffer as we have seen it with the transaction ID. So it's in the response here. And then the value is also the, you see here this quotes. So this quotes is from my testing. So when we use this in the basic chain code, this example underscore 02 chain code, where we can store only the value A and B, and we have the amount of values from A to B, then we will have as a return here, not a JSON object. So we will have maybe a key, a string, and when this string is a string with space, then we will receive an error here. And to get around this, I have wrapped this in this quote. So that's the reason why for this test I have here this quote. But for the JSON object, we don't need it. And yeah, timestamp, and that's, it's deleted. So that was also a question from the channel, from the Slack channel last week. So immutability is one key for a blockchain. So in a blockchain, you can't delete the history of an asset. So when we delete this, so only the state is deleted, and we cannot delete the history for an asset. So that's something you have to know. And that's also when you come from a developer side. And yeah, so we have to think in a different way. And so that's a key functionality for a blockchain. So we can mark an asset as deleted, but we cannot delete the whole information which is stored into the blockchain. And yeah. Okay, so okay, that was a short overview over the chain code. So the chain code is into the into my GitHub repo, so you can go through this and you can see this. You can study this, you can test it. So one method is left here. So maybe someone of you want to extend this. So the delete function, so the delete functionality is left here. So we have to bring in here a new function to delete an asset. So maybe someone of you want to try this. Then he can copy this chaincode, and then he can modify this chaincode by his own, and he can try to extend it to delete one asset. Okay, so that's from the theoretical part. So now let's move. So let me see what I have on the slides. So before I come to this, so okay, this we can look a little bit in this. So the difference between key and transaction ID. So in this short image here, we can see the different. I have tried to explain this here. So when we have an asset, so the key point of an asset is that we have a key and a value. So the key is a string, yeah, a unique string, and the value are the bytes we have seen. So, and that what will be stored into the blockchain. So, but we can have a huge JSON object, we convert this to bytes, and then we have only here the key and the bytes. So that's an asset. So, and every asset is displayed in a state, and the state is the last version. The world state is the last version of this asset. And to create an asset or to change an asset, we have a transaction. So, and this transaction has an ID and has a lot of informations in. And when we make this transaction, we have an ID, and this ID stands for exactly this state. And when we update this asset, we have another ID, and this transaction stands for exactly the second state, and so on. So the transaction IDs are always unique within the scope of the channel. I have written this here. So, and what I have seen, that's something I would like to show you in a moment. So that's the read-write set. So when you look to the documentation and then you read it, then you will see the term read-write set. So that's a part from the administrator course, I think, so that we can see what is the read-write set. And this is the transaction. So, and when we see how that's a huge JSON object to query the final transaction, and it's really interesting to see which informations are in this transaction. So that's really interesting. So, but the transaction ID is unique, identifies uniquely the transaction on the channel. So that's important to know. That's only on the channel. So we have a channel, we have a chaincode installed on this channel, and this channel, the transaction ID is unique to this channel. And the same for the key. So the key is also unique in the scope of this channel. So we can have a second channel, and then the second channel we can use the same key, or maybe we can have the second transaction ID. So, but the key is set from you, from the developer side, and the transaction ID is created through Fabric from the SDK, or from the Node.js or the Golang Chaincode. So, okay, so now let's start this. So when we are going to try this, so, and to start this network, a little bit smaller, so, and we have to start. So what I'm going to do now is I start the build your first. network example script. So with the 2 organizations, the 2 peers per organization, 1 certified authority per each organization, and for every peer we have a chain code. We will use Chaincode as a state database. So, and as I have mentioned here, so the N option here is the key for this. So the network is created, the crypto material is created, the channels are created and joined to the peers, and everything what you need that this network is running will create it through this script. And but no chaincode is installed. So, and then we have to install the chaincode by ourselves with these commands here. So we have to install it, and we have to instantiate it on one peer. And this take 1 minute. So I think the 1 hour for this example is too less. So I try to move on, that we don't have so much overtime every time. So, but 1 hour is too less for these examples, I think. So, okay, so the network is ready, but okay, we use Docker stats so that we can see, okay, so now here you can see this now. So one important information now, here you see in the first line def p0 org1. So, okay, this is the only chaincode container which is now running. We see our peers, we see the certified authority as a Fabric CA, and we see the orderer, and we see also CouchDB here. But we see only one chaincode container. And that's also important finding out to know that the chaincode is executed in a single container, and this is called the chaincode container. And you see this is here only for peer 0 or 1, the chaincode container. And so that's it. And the next thing what we are going to do is we have to use this. So for this, we can use our Node.js application. I have modified, I have rewritten this application in a way that we can use this chaincode functions, but I think it's too time consuming to go through all the steps. So I will show you only the key parts from this. And if you want to know how you can do this, then you can look at the GitHub repo, and I think I have comments on every line. So you can see how this works, and you can easily make your own application based on something like this. But now we have a running Fabric system, and now we want to use a client application and Node.js application to query, to create an asset, to update an asset, to update an asset again. And then we want to see, okay, what are the transactions from this asset? And then we are going to query one single transaction from the past. So these are, but to do this, so we need something more than the Node.js code. So the first thing what we need, so the first thing what we need is a user. We need an identity. So to query this, we don't have a username and password like in any other application. So we need an identity. And this identity is stored into the wallet. So here is an identity. So we clear this. So now. And how we can get this identity. So this is a part which we have seen 2 sessions in the path. So where I have explained how you can connect to this network, how you can use the connection profile for this, and how you can register or you can add the user to the wallet. So this I would like to skip now. So I only want to use this. So, and we use the same script as we have seen in the past. So, and this is the script add to wallet. So this is also, you find the script in his original way also in the Fabric samples. And we do this for the user 1, org1 user. So this for in the setup process from this example, there are 2 users automatically created, user 1 and then admin user for every organization. So, and we use the user 1 to use this in our Node.js application. And there are 2 ways where we can get an identity, and valid identity for this Node.js application. The first thing is that we use the add to wallet method. So that means that we have already user credentials, we have registered users, the user is enrolled, and that's what happened when you use the build your first network script. And the second one is that you enroll an admin from the Fabric CA, and then you register with the script your own user against the Fabric CA, and you can then register and then enroll the user for the Node.js application. So that also depends on your business needs, and there are 2 ways to do this. The shorter way for now is the first way. So we have a user 1, and we have also the crypto materials from this user. The only thing what we need here now is the private key from this user. So, and this is an important part to know. Every time you start your build your first network example, then the crypto material is every time is new generated. So that the names are the same here. So I have here a config object, and the names are here hard coded, and yeah, the names are always the same, the paths are the same, but the private key here is changing every time. So we have to now show what is the private key for this user, and copy and paste this to this position here, and then we can use the script to enroll the user. So, and that's, we will look so this is done. There will be network crypto config. Work 1 example, then users. This is user 1. Yeah, every user. So you say here the structure is basically always the same. So we have P organizations, we have the one organization, you have on this level or organization 2 or 3 or whatever, and then you have a folder users, and in this users you have user 1, user 2, and the admin user, and then you will have the MSP folder. Yeah. So that's the membership service provider folder. So that's the important part for us. And from this part, we need the key store. And in the key store, this is the private key. So, and this key we have to fill in here. So, and with this, we can call a node add to wallet. And when he is done, we can look at tree wallet, and you see here we have now the user 1, we have the private, the public key, and here the meta informations, which we have also seen in the sessions before. So now we have a valid identity. And with this in mind, we can start our application. And for this, I use NodeMon. because when you develop a Node.js application, so it runs, it is a process, it has to run. So, and when you make a change to this, then you have to restart the application, and NodeMoon does this job for you. And that's not for production, so that's only for development. And when we start this, and we have connection to the network ready, API service is listening to 3000. So now we are a running Node.js application here, and we have also a connection to the Fabric network. So this is basically done through the connection script, which we have seen in the last sessions. So I have changed here nothing. So that's basically always the same. And now we have to, and I have here tests. So we use the npm test functionality to create an asset. So, and the first test here, this is the check, this, we don't need this, so we need this. So, and now the first thing is we want to add a new asset. Oops, we need a new asset to the blockchain. And here we see the data object. So now we can, and we see here we have a payload, we have a value, and we have a data. So, and we can pass the whole object here, and to the blockchain. So, and this could be done with the npm test. It's also the same. And now look at this Docker stats. You see here, new chaincode containers are created. So, but for the first time, it takes some time to create and build the chaincode container for every peer. And because we have set in our endorsement policy that we has the AND option. So one for every asset, we need a confirmed transaction from one peer in the organization 1 and for one peer in the organization 2. So, and now we will have here 2 more chaincode containers. Yeah, we have here dev peer 0 from org1, and we have dev peer 0 from org2, and we have here dev peer 1 from org1. So, and now, okay, this error message is okay because it was too long, it was a time limit, but the transaction is valid. So we have here our key, our asset key, and here we have the transaction ID. So, and when we look at this add, so here you can see this, it's very easy. So here I have changed, I have skipped the unique ID from the chaincode, and I have created here a unique ID from Node.js, from the Node.js side. And I pass this here, the key and the value. And the value is data object, as you see here, a JSON object. And we have to stringify it with JSON, and then we can send it to the transaction, the contract submit transaction function, and then we can print out the result. So for this, I need the unit util format function that we can have here a nice formatting. So, and now we can check this also in the CouchDB. So when we look at CouchDB, so, and then we have here the CouchDB administration. So, and here is my chaincode, and you see here our asset. So, yeah. And you see here this ref, this underscore ref attribute, and you see here first. So that means, okay, that's the first step. And now we are going to use the second test. So we need now this transaction, this key. the unique key. So we skip the add method and we use the update method. Fill this in here. So, and yeah, that's another text. So we have the name, we have a description. Yeah, but we don't change the owner. We don't change the type here. Okay. And we do the npm test again. And you see now, okay, another chain, the last chain code container is created. So because organization 2 has no chain code container for peer 1, and it's now also created automatically. And then we will have a second state here. You have the key and you have the second is the transaction ID from the second state. And when we look here, so one Mongo query, so and here, so and you see you have the second one. Yeah. So the owner is everything the same, the type also, but we have changed the name and we have changed the description, and we have here revision 2. And that's an indicator that we have a second state for this. So now you can, it's a little bit faster. So, and then, so these are the queries. I think that's pretty straightforward. So we can query by ID. You have to fill in here the key. Yeah, the owner, so you can create the owner, so you can write here the owner as a string, so you can have here the ad hoc query where you can pass the selector, also the use index element here, as we have seen last time. So the last two things we are going to see here is now this one. So we are going to try the get all transaction by ID function. So. And you see here, I have the result a little bit modified that we see this a little bit clearer. So when we now start the test function, and you see here, we have 2 transactions for both states. And here, but so maybe we, it's a problem from the scrolling. And then we say, okay, that's the first. Then we want this one. Fill this in. And we see this one. So, and then we call this test. And now you have queried the state or the read-write set. It's not the state. So technically, I think the right term is the read-write set from this transaction. And but this could be wrong. So this could also be a not valid transaction. And I will show you in the get transaction function. So how you can query this. This is a little bit different to the other stuff. So, but in every query, so when we say here, so we have a contract, and this contract is delivered from the connection, and then we can evaluate transactions. So we call this function. So, and in this way, everything works. But for this transaction, we have to use a different method. So we need the gateway. So, and our connection here delivers in the result a gateway and the contract. So that's the gateway object from the SDK. So yeah, and the contract which we are going to use now. And to query this, that's the important part, is that we pass this to the endpoint, to the query endpoint. So we have to pass the gateway, yeah, and the config. So because this config object is only for the channel name. So, but we have to pass the gateway to this API endpoint. And in this API endpoint, we can, in this gateway, we can create the client. So we can call a method get client, and now we have the corresponding client to this gateway. And in this client, we have a method, this get channel, and this delivers the right channel for this client. And then from this channel, we can call a query, we can call a function which is called query transaction. And that needs the transaction ID, which we have created before. And this delivers a payload as a response. So, but this is a really huge JSON object. And to come to get to this point, to this information, so this information, the key, so this is the read-write set. I think it's the read-write set. It's not an asset, it's not a state. So this is the read-write set, which is sent to the blockchain. And if it's valid, it's exactly the same like the state we have seen in the couch tree, for example. So, and so maybe, I don't know, so maybe someone of you has a better way to query this state. So, but I don't have found a better solution for this. So, and when you play with this, you can print out when you print out this result, then you receive a huge JSON object with a lot of information about this transaction. And that's very interesting to see what is in a transaction. And you can find out a lot of information. And it's also important to see what is in this JSON object to learn how Fabric works and what are in this, which elements are involved and so on. So it's pretty interesting to see what is really into the read-write set. And that's really a huge aspect here. So, but when you have this, then you can, it's a JSON object, then you have to pass this JSON object, and then you can here construct the result object here. The key is the transaction ID, and the read-write set is here there. Yeah. So that's, I think, from my side, but one thing is left. So the last thing, my learning. So what was my learning through this journey? So my problem was with this, I received the following error: failed to submit transaction and code endorsement policy failure. So what does this mean? So I have created and I've Googled and created this, and I haven't found a good solution for this. But the problem here, the lesson I have learned, is not that I have it was a problem in the Go code or in the Node.js code. So, and also not in the setup from the test network. So everything worked, but a completely different thing happened. So, and that's a part which I have not really recognized in the moment where I've designed this chain code. And the reason for this is, in my last presentation last week, I have created the unique identifier ID into the chain code. And I have also, to demonstrate how we can query the timestamp, I have created a timestamp into the chain code. So, and I have stored this into the blockchain. And I used the OR operator, and it works. So, because only one peer has to successfully endorse this transaction. And when I try this with the AND option, so that also the second organization has to endorse this policy. And the sense is that both organizations must come to the same result, then that can't be happened, because when we create a unique ID in the chain code for the peer one, you can see here, this is the simplified process. So the SDK here, the Node.js SDK, sends the call to the P0 to the chaincode. The chaincode is executed, and then in the chaincode, a new unique ID is created. So the name is the key. So unique ID. So that's a unique ID, and it delivers back a hash from the a hashed value, and the same happened on P0 org 2. Yeah, these are completely different things. So the chaincode is the same, but the chaincode does the same. So it created a new unique ID. So and then we have, oops, and then we have a response here in a hash, but these are completely different hashes, and this leads to the endorsement policy failure, because I have tampered myself in the chaincode or something like this. So it's completely stupid. But what is this? What is the lesson? The lesson is that my background is I'm a background developer and a backend developer, and I have a special kind of thinking how an application has to be developed. So when you send some data to the server, then the server has to create a log ID, the server has to create a timestamp, and so on. And that is the thinking. But when you create a blockchain application, you cannot create in this, you cannot think in this way, because here we must come to the same hash value. Yeah? And then when we receive the same hash, yeah, then the transaction is valid. So that means that when we execute this chaincode, then we can have here a tampered version of this chaincode, and we will get the wrong results. And that's the heavy lifting that the SDK for us does. So, and that was the problem. So, and the same was with the timestamp. So the timestamp was milliseconds later, or nanoseconds. So Fabric goes to nanoseconds. So, and the chance is really high that you will have a different timestamp on the second chaincode. And when you have a hash, so we have a SHA-256, I think so, then when you change only one byte, you will receive a completely different hash value from this. So that's the sense from a hash. So the hash value will be completely different when you change only one byte. And that was my learning in this week. So I have to think as a blockchain developer. And when you build such applications like this, then you have to know exactly what you are doing and how this works in the whole way together. So it's for the Node.js developer also important to know how Fabric works, how the transaction flow from a Fabric application works. And to know this and to understand this, and also to have this in your mind when you create this application, that's a learning process. And this is an example for me to see that I must think in another way if I develop blockchain applications for this in this way. So, but when you see this, and when I tell you this, then you say, okay, it's completely clear. Yeah, but when you do it by your own, then sometimes you don't see this, and yeah, that's the reason why learnings and the expression of some learnings are so important, that others can learn from these mistakes. And that's really a good example how you should not do some things in the blockchain. And yeah. Okay, so what we have here. So yeah, the last thing only. So is here you can have, I have three references for you. This is the Chaincode Go shim documentation from the Go code. So that's really good to look through this, that you see which functions you can call. Then the same here from the Node.js. And here on my GitHub repo is the repo for these examples. So you can find here. Yeah, that's funny. Yeah, so that's a loadish vulnerability. So, but doesn't matter now. So, but here you can see this is the supporting material. So this is the way where you can create the space network. And here you have this this script, and there was a stop script. So you can, if you stop this, and here you have the Node.js application. And here you have the Chaincode. So this is the Chaincode. And here you have also the way. So in the last sessions, we have seen a little bit more the Chaincode Docker dev mode environment. So this is also a step-by-step guide where you can start these 3 panels, which I have seen here. I use this terminal multiplexer for this, and yeah. So that's for the development of this Chaincode, so you can test it. And then it's also for the Node.js developer, when you come from the web development, it's really important that you can test your Chaincode with the CLI container. So that's the first line of test which you can do to see how this works. So, and in this Docker dev mode, it's very simple to do this. So you don't have to take care on crypto materials and TLS certificates and so on. And so in this way, you can test your Chaincode very easily. That's here. And here's the Chaincode. So we have seen. And here also the indexes I have used. So that's only one index now because I have skipped the time. So the time property. So that's also a part which we can now improve, that we can index sort by time. When you something sort in CouchDB, you need an index for this, and so this. But this is also part from the last session. So yeah. And yeah, these are the references. So I think we are done. Thank you for your attention. And if you have any questions, you can put this in the Slack channel, or you can ask me now. I am open for 2 questions, and